When determining if a set of data are linear, you verify that the data had a constant rate of change, or a constant slope, from value pair to the next. When determining if a set of data are exponential, you need to verify that there is a constant ratio from one value to the next. So to find the constant ratio, you're going to take two sequential y values and write them as a ratio or a fraction. Then you're going to go to the next two and so on until you've done them all, or while you're working on it, you can prove that the ratios are not the same. So this is what we're going to use here. We need to find the ratio, and it's always going to be the new value divided by the old value. So here's our first set of data, and we're going to see if it is exponential or not. So again, I only need to focus on the y values. So I'm going to start off with these two here, and I'm going to do new divided by old. So the new value is going to be 1, and the old value is going to be 1/4 because it's going in order from top to bottom. And if you're not sure, just look at the x values. This will tell you which one's new and which one's old. So I'm going to do 1 divided by 1/4, and when you simplify that, you're going to get 4. Easy enough. Now we're going to do the next two. And again, new divided by old, so 4 divided by 1. So 4 over 1 is 4. Looking good so far. Now we're going to do it again. 4 and 16. So 16 over 4 is going to give me 4. 3 for 3. And now I'm going to do the last one. I'm going to do 16 and 64. So 64 over 16, and that is going to give us 4. So there's a constant ratio of 4 the entire way. So we know that the data are exponential. So since it is, we're going to write a function that models it. Now, the exponential model follows that y equals ab raised to the x. And so 4 being the constant ratio, and the constant ratio is b. So b equals 4. So we got what b is, we still need to know what a is. Well, a is the initial value. And you can find the initial value by finding what it is when x is 0. So when x is 0, y is 1. So we know that a equals 1. So to write my equation that models it, my function, y equals 1 times 4 to the x. And we really need the 1, so I'm just going to say y equals 4 to the x. And here is the function that models this set of data. Let's do it again for this set of data. Again, new divided by old. So here's my first two, 4 over 2. So 4 over 2 is going to give me 2. So far, so good. And now I'm going to do 4 and 6. So again, new divided by old. So 6 over 4 is going to give me 3/2. These are not equal. So I can say that this set of data not exponential. In fact, the data are linear because everything's going up at a constant slope. So this is a linear set of data, but since we're only focused on exponential, we don't have to go any further since we proved that is not a constant ratio from y value to y value. Here is our last set, so we're going to see if this is exponential. So 3/2 and 3, so it's going to be 3 over 3/2. And reducing this down, you're going to get 2. All right, let's do it again for 3 and 6. So 6 over 3 is also going to give us a 2. Looking good so far. Now let's do 6 and 12. So 12 over 6 gives us 2. Feeling pretty good about the last one, but we're going to write it out just to prove it. 24 and 12. So 24 over 12 is going to give us 2. We can see there's a constant ratio, so this is exponential. And again, before I can see that since my constant ratio is 2, that b equals 2. And since my form of an exponential function is y equals ab to the x, I still got to find a. I can do that by just going to find out what my x is. X is 0, so that means my a by default has to be 3. So a equals 3. Just take these and plug it in, and I'm going to get y equals 3 times 2 to the x. And here is my exponential function that models this data.